Hello friends, welcome to episode 2 of Haskelling in Hackerrank. This is a series where we try to solve problems on Hackerrank in Haskell. If you haven't watched episode 1 yet, I will highly recommend you to pause this video and watch that first, as we will be using some of the input parsing techniques we learned there in today's episode. That being said, let's see what the problem is today that we have to tackle. The problem is called minimax sum. Basically, in this problem, we will be given a list of positive integers and we need to choose 4 integers out of that list and sum them to find the minimum and maximum sums. The approach is simple. Basically, we have to sort the list, and for the minimum sum, we take the first 4 and then sum them up. For the maximum sum, we take the last 4 and sum them up. For sorting, you can implement your own quicksort or merge sort algorithm, but it is much easier to use the sort function provided in the Data.List module. So let's import the Data.List module. Let's reload the project and I'll show you the type definition for sort function. So basically, given any type which is orderable and the list of that type, you can get the sorted list back. So let's say L is 5, 1, 3, 2, 4. Then if you can do sort L to basically get the sorted list back. So our problem here is to find like a minimum sum, which let's say takes a list of int and then produces another int. So min sum ends is basically you sort ends, and in this case we know it's always going to be 5, the list of 5 integers, and we need to take the least 4 for min sum and then max 4 for the max sum. So instead of take 4, we can just write init, right, and then sum them up. And we are doing the same eta reduction that we had seen in last episode, basically just defining min sum as this expression by removing the argument. Let's do the same for max sum. The signature is same, and max sum would be sum of tail and sort. Basically what init does, discards the last element of the list and keeps the first ones. So basically it discards the 5 here, and tail does the other way around. It basically discards the first element and then takes the last elements. So yeah, so we can calculate the minimum sum and maximum sum and then collect them to a list. So let's say min sum L, max sum L as a list. Then we can do the map show on that to convert each of them into the string. And then in order to actually produce a string where these two integers are space separated and it's a single string, we can use the unwords function. It basically does what words does, but in the opposite way. It takes a list of strings and it produces a single string separated by a space. So for example, here in our previous expression, if we do unwords, then we get 10 space 14. So let's just do that. Let's define a function sol, which takes a list of int that we can parse from the input and then produces a string. So sol ns would basically do unwords and then composed with map show applied to the min sum ends and max sum ends. Here notice that ends is intermingled with all the functions that we're using in this expression, so we cannot do the eta reduction like we did for the min sum and max sum functions above. Okay, so as usual we'll be using the interact function. We'll get the whole input as one string, so we separate the string of integers into words. We can do map read to convert them into int, and then at this point we get a list of integers, so we just pass it to the sol function and that should give us back the string. Let's compile everything, it's all good, and let's see if we can submit this code. So I've copied over the code that we just wrote and I'm going to replace all of this huge boilerplate code that they have written and just paste our code. Let's see if Hackerrank can run our code. It can. Looks like we got the correct output. Let's submit the code. All test cases pass. Congratulations, you just solved another problem on Hackerrank in Haskell.